Hello everyone, this is Professor Robert Solis. Welcome to this video lesson. We are going to investigate the repetition structure, but we're going to create this project here. I'm going to call it the water tower calculation. And so the idea is this. Let's say that you have three neighbors who live in a rural neighborhood. They own farms and they have farm animals. And they decide, you know what, let's put up a water tower. I think we would save money, the three of them say, if we would put a water tower somewhere in between us, and that water tower is going to help service our water needs. The question is, where should we place it? So they hire a computer scientist to say, okay, look, I live here, my neighbor lives over here, my other neighbor lives over here. Where should we put the water tower? All right, so we're going to allow the user to enter where the houses are located on a Cartesian coordinate, and then we're going to show the houses, and then we'll show the tower. So how shall we go about solving this? Well, I drew this graphic here to help you illustrate, or to help you understand through this illustration, how we're going to solve this. First of all, you'll notice that house 1, house 2, house 3, they form a triangle. Now, that means that the water tower has to be somewhere in that triangle. And that somewhere, or that location, we call that the centroid. So where should that position be? Well, you'll notice that the centroid yields the smallest distance from house 1 to the water tower, house 2 to the water tower, house 3 to the water tower. We're going to call this distance D1, D2, and D3. What we're going to do is we're going to add up those three distances, and the minimum total distance is where the water tower should go. All right. How are you going to determine that distance? We're going to use the distance equation. So the distance equation is simply the difference of the x-axis points squared plus the difference of the y-axis points squared, and then quantity square root of the whole thing. That's going to give you the distance. So if I said, hey, what's the distance between house 1 and the water tower? I plug in the points here and here, and then I'm going to get that distance. And I have to do the same thing for D2 and D3. I'll add those up and I'll get a total distance. So here's how you're going to solve the problem. What we're going to do is we're going to place the water tower right here at 0, 0. And then say, okay, what is the total distance? Then we're going to place the water tower over here at x-axis 1, y-axis 0. And then ask, what is the total difference? Is this total distance less than this one? Because if it is, then I want to remember this position right here. Then we're going to move the water tower over here. Here, 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 and then when we're done, we'll move the water tower to the next row right here, and then we're going to test these intersections. And then when we're finished, we're going to move the water tower to this section over here, to this intersection, and again, test all these different intersections. And what we're trying to do is we're trying to find, as we're doing this, the least total distance, because see, this represents pipe. The water tower to this house, the water tower to house 2 and house 3, that's a pipe right there. And linear pipe is very expensive, galvanized linear pipe. So we want to minimize the amount of galvanized linear pipe that we need so that we don't have to buy a tremendous amount of it. So that's why they're hiring a computer scientist to, okay, figure this out for us. Where should that water tower go such that D1, D2, and D3 are minimal values so we don't have to spend as much money as if we just kind of guessed, well, the water tower should be here or here or here. Now, I designed this Excel spreadsheet to say, okay, let's put three different houses. Okay, so let's see here. Let's go to this one here. This house is at 1, 1. So I'm going to put house at 1, 1. And then this next house is over here at 4, 7. Okay, so this is at 4, 7. And the next house is at 6, 3. So x-axis 6, 3. So what this is saying is that the water tower should be at x-axis position 4, y-axis position 4. Okay, so let's take this water tower. Oh, look, I already put it there. Position 4 and 4. That's the best location of the water tower. That's at the centroid of this triangle that's being formed from this from the location of these three houses. Now what I did was, you'll notice all these other numbers. So what I did was I said, okay, what if the water tower was over here? What would be that total distance? D1, 2, and 3. Well, that'd be 12.9. What if I put the water tower over here, or here, or here? So these numbers represent the distance the total distance, D1, D2 plus D3, based on the water tower going here at x-axis 1, y-axis 3, or over here, x-axis 9, y-axis 3, so forth and so on. And if you'll notice, this value right here, 9.48, it should be the minimal value compared to any of these other values. So in other words, the way that I've written this Excel spreadsheet is I've said, here's the equation. Here I've said wherever the smallest distance is highlighted in blue. And sure enough, 9.48, you won't see anything less than 9.48. You might find something possibly equal to it. I think that comes close, 9.58, but you won't find anything less than. So this is the best location right here that's going to yield the least amount of total distance based on the houses at this location. Okay, so that was a little tool that I developed just to verify that in fact I am answering this question correctly when I develop it. Okay, so another thing to consider is this. We're going to create a, I'm going to go back over here to the handout. We're going to create this, this form with these group boxes and these drop downs, and these buttons and these lines. These are nothing more than labels. And I want the user to just simply add the houses, and then I'll say show houses, and then H1, H2, and H3 will just appear. Well, how do I make these guys appear? Well, as it ends up, the origin of the form is right here in the upper left-hand corner. I know that sounds weird. You would think that maybe the origin is down here at the bottom left-hand corner, but no. The origin for forms is right here for any of the Visual Boards, Visual Basic, Visual C#. It's right here. That's the 0, 0 location. So that's why I say absolute origin is right here. But of course, our relative origin is right here at this point. I don't know what's that. That's at x-axis, 50, y-axis, well, actually it's coming down from here, y-axis, maybe 300. That's the relative origin. So when we move a house from here to here, which is 1 over x, 1 over y, we're not, that's based on the relative origin, this guy right here, but of course the relative origin is relative to this absolute origin. So I have to find out where this point is, and then from there, add whatever the distance is supposed to be. Well, how do you do that? Well, let's go over here to this picture. And the way that we're going to do that is as follows. We're going to have to determine what the separation of these lines are. And whatever that separation is, whether it's 40 points, 50 points, whatever that happens to be, we're going to call that delta. And so what we'll do is we can use a labels dot left and also a labels dot top position. And so what we can do is we can say, okay, the dot left position of a label is at, and here's the formula that we'll use. Whatever the x origin is, and so as you can see here, that's this point right here, whatever the x origin is plus h1 times delta. So this is the formula that you'll use to determine the location of the x-axis for the house 1 and the y-axis for the house 1. Notice the minus sign. Because remember, the origin's right here. So this is positive 10, positive 20, positive 30, 40, 50. So if I want to go up, I'd have to subtract. 50 minus 10 is 40, 40 minus 10 is 30, 20, 10, 0. Right? So moving down, moving a house down or moving a label down increases in value. But if I'm doing this, moving a house up closer to the origin, it's supposed to be decreasing in value. So that's why I have subtraction right here. Okay? All right, so hopefully you get those concepts because we're going to need that in terms of the creation of our project. All right, so let's go over here to Visual Studio and let me go ahead and create a new project. Let me go ahead and click on C# and let's see here. I want the Windows Form application. This is going to be my CS 111 course. And let's see here. We're really talking about repetition and specifically the water tower. That's the water tower project, which I think I said was Lab 10. So Lab 10. Okay, let me go ahead and click OK. And I know that I'm going to need my toolbox, so let me go ahead and click that once the form is displayed, which it should come up any second. And let's see here, not this guy. Toolbox, that's what I need. And tack that down. We go back and forth between the preview. So it looks like, first of all, I'm going to need some group boxes, and then I'm going to need some buttons. I think I'm going to design this later. Let me do the more difficult thing, which is design this grid. Okay, so the first thing that I'll do is I got to make sure this thing's big. So something like this. All right, let me just drag and drop a label. And that label, I'm going to need to resize it. So I'll take away the toolbox. And that means that I'm going to have auto size false. Then I can resize this thing, right? And let me put a border color, or not a border color, a back color. So the back color is going to be black. So I just said back color, drop down, click the custom tab, and click the black paint chip. Okay, so you can see that I can reduce this, but I can only reduce it so much. It looks like it only allows me to have a height of 10 and a width of 10. But I want to make a smaller line than that. So what I can do is go to the size property, and let's say if I make this a height of 2, and let me unselect it. That looks pretty good. Maybe I want to select, make that a height of 1. I like that even better. Okay, so all I did was select the line, like that, or I can just simply select it like this, and change the size, height to 1. And you'll notice that over here I have the, I have this location of the line, I don't know, whatever that distance is, let's say 50 and maybe 10 or 40 from the top. Let's just play around with it. Let's see what happens. So I'm going to go to location, and let's say for X, let me type in 40. Okay, that looks pretty good, but it looks like I'm going to need a little bit of distance because I need to put some labels here. So I need a little bit more distance than 40. What happens with 100? Okay, 100 looks good. That's a good distance. I can put a number over here, and that's probably overkill, but 100 is fine. How about the y-axis? So let's see what happens if I type in 20. So you'll see how if I type in 20, that's the distance between here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 20. All right, so what happens when I double that to 40? See how it's moving down? How about 60? Enter. How about 80? Enter. How about 100? Enter. So do you see how as the number gets bigger and bigger, it's moving down? All right, according to this, I mean, there's a little bit of distance here, but not much. Let's see, will 20 do? That looks pretty good. How about 30? I think that looks even better. So we'll just make that 30 right there. So this is right here at this location, but I don't know how big this is supposed to be because it just depends on this distance right here that I'm going to create, and then I have to create a total of 15 of these. So I don't know how big this is supposed to be. I'm going to make it on purpose a little bit wider, and then I'll probably have to make an adjustment. All right, so in terms of the width, let's say 500. Okay, again, I'm totally guessing. I don't know. We'll have to see what happens. I think what I should do is I should put these, I should create a bunch of these, specifically 15 of them. Right? Isn't that right? 1, 2, 3, 4, 5, 6, 7, 8, 16 of them if I include that bottom one right there. Okay, so what I'll do is I'll just take this guy over here, and is there a duplicate? I don't see a duplicate, but there is a copy and paste. So I can just simply copy and then paste. All right, here it is. Now I have to be careful because if I have this, if I have this, that's not going to work. I need this guy right here where I can move it. And see, I can move it right here like this. Okay, now I have this guy over here at, let's see here, what's the position or the location? This thing is at a location of 30. What I'm going to do is I'm going to separate them by 40. So that means that this should be 30 plus 40, which is 70. So let me select this guy over here, and we'll make the location 70. Okay, because I want a delta or a difference of 40. All right, and by the way, both of these should be the same x-axis. So that's 100. This guy should also be 100. Yep, okay, good. So let me take these two. I could just take this one, that's fine. Copy and paste. And I know that the x-axis has to be 100, so I'll just type in 100. Now, if this guy is at 70, 70 plus 40, that would be 110. So that means this guy's got to be at 110 in terms of the location right here. Hey, that doesn't look right. Did I make a miscalculation? That's 70. 70 plus 40 should be 110. Oh, sorry, I said 100. 110. There we go. That's better. Okay. No, we just got to keep on doing this for every single one of these lines for 16. So let me go ahead and copy and paste this. That's going to be 100. And if this guy is 110, then that means that this is going to be 150. Okay. Then we'll say paste. Oops, sorry. Let me undo, because I think I pasted accidentally. Undo. Oh, and then we redo. That's fine. Take this guy, copy and paste. Again, it's going to be at 100 for the x-axis. This guy over here is at 150 plus 40 is 190. 190. Okay, take this guy, copy and paste. That's going to be at a 100, the x-axis. And if this guy was at 190, then we have this at 230, because there's a 40-point delta between all these. Okay, so we're just going to do this step by step here. So 100. And if that's at 230, that means that this guy is over here at 270. Copy and paste. This is at 100. If that's at 270, that means this is going to be at 310. Again, copy and paste. Oh man, I didn't mean to do that. I didn't mean to double click on the form. I'm moving too fast. And so well, I'm just going to leave that here because a form load, yeah, I guess I will be doing stuff in here. I'm just going to leave this as is, but I got to be careful. Let me save all. We don't want to double click on anything, so I'm going to be moving a little bit slower. I want to move fast because this is going to be a long video lesson, and I'm trying to speed things up. I shouldn't be doing that. Okay, so that's at 310, which means that that's going to be 100, and instead of 310, 310 plus 40 is 350. Okay, looks good. Take this guy over here, copy and paste, 100, and the other one was at 350, which means that this is going to be at 390, because 350 plus 40 is 390. Let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need a total of 16 of these. I could do something like this. First of all, let me make this form just a little bit bigger. Go down here. Can I make it a little bit bigger? I shouldn't have made them so big. Maybe I should change the delta to 30, but it's too late. I'm committed. Let's see. What did I say? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So let me select 1, 2, 3, 4, 5, 6. I could try this, copying and pasting this, and then very carefully waiting until my pointer turns into a move pointer. And let's see here. So let me move it right on top of this. And I know it's supposed to move down 40, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14, 15, 16, 17, 18, 19, 20. I just used the arrows here to bump them down. Well, if this guy over here is at location 100, 390, the next one should be at 100, 430. So let's see here. Is that right? 429. So 100 is good. 49. So in other words, these are all off by 1 pixel. So let me select these and hit the down arrow once, and then that should take care of everything. So let's see. This guy over here is at location 430. This next one should be at 470. Yep. This next one should be at 510. Yep. Okay. So they're all fine. So I just did like a copy and paste there to help me speed things up. All right, well, it looks like my form can be a little bit smaller here. Not too small. I gotta accommodate the label. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, good. So let's see here. How about maybe be careful here right there. I think I'm going to have to put some labels down there, so maybe I should Maybe, you know what I should do? Well, that's okay, that's fine. I'm just going to have to make this a little bit bigger because I got to put some labels down there. So right there is fine. Okay, now I'll just take this label, copy and paste it. I've got to make some vertical lines. So I guess what? I'll just do this. Something like this. And that's got to go up to here. So let's see, will it snap to this line? Yes, it'll snap to here. Will it snap to this guy over here? Yep, right there. Okay, so what is it saying here in terms of the size parameter? What it's saying is at 599. Well, that can't be right. It's got to be probably at 600. So let me go ahead and change that to 600. Enter. Of course, the width is wrong. I'll change that in just a second. In terms of the length, or location rather, it's saying that it's at x-axis 480. I'm going to change that to 100. There we go. And the y-axis, I'm going to change that to 30. Enter. The reason why I did that is if I select that first line, you see that the y-axis is at 30. So for this very thick line right here, it also has to be y-axis location. And in terms of the size, we're going to change the width to 1 point. All right, there we go. So there's our line right there. Now I just got to take this and I'll copy and paste. So copy and paste. Now in terms of the location, the x-axis, well, if this was at 100, 100 plus 40 is 140, so that should be 140. Enter. Now in terms of the y-axis, that should be at 30. That top point should be right there at 30, because that's where this line is. It's 30 from this top right here. This is the origin, so 1, 2, 3, 4, 5, 6, 7, all the way to 30. That's where the origin is. Okay, so I think I'll just take these two, copy and paste, and let's see here. Where is this supposed to be? So if that's at 100, that's at 140. This guy over here should be at 180. Where does it say the location is? Well, it doesn't because both of these are selected. So what I'll do is I'll just simply eyeball it. Actually, all I could do is I could just do this. Just put it right on top of it, approximately. And let me just eyeball it. So, and then I can make a correction. So let me unselect, just select this guy right here. And where is that located at? Okay, that's at 180. Now, I think this guy over here, this guy is located at 140. 140 plus 40 is 180. Oh my gosh, can you believe it? My eyeball actually worked. It's at 180. And look at the x-axis, or the y-axis rather, is at 30. So this is perfect. Wow, I can't believe it. Then we take these and copy and paste. I'm going to try eyeballing it again. That's not right. That's not right. This guy right there. That's going to allow me to move. And that's too much. Let's try right here. Let's see what that does. So if this guy right here is located at the x-axis, 30, 30 plus 40 is 70, so this guy should be at 70 in terms of the x-axis. Let's see here. This guy is, oh, I'm sorry, I read the wrong value. Sorry about that. This is at 220. That means that 220 plus 40, that should be 260. So is this guy at 260? 261. Ooh, one off. Okay, so what I'll do is I'll select all these, because that was my copy and paste. I'm going to touch the left arrow one time. There we go. Now, if I select this, that should be at 260. This should be at 300. Yep. This should be at 340. Yep. And finally, this should be at 380. Yep. Okay, good. Finally, I'll take these, copy, and paste. And let me just move them into location. Again, I'm just eyeballing it approximately right there. Okay. All right. So if this line right here is at location 380, 380 plus 40, that should be 420. So that means that this guy over here is going to be at 420. 421, one too many. So what I'll do is I'll select these guys, which I just copied and pasted. I'm going to hit my left arrow once, and now everything should be calibrated. So let me just double check. It looks like that's at 420. My eyes are over here. That's at 420. The next one should be at 460. The next one should be at 500. Okay, perfect. I need 16 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, good. So now I know how wide these horizontal lines should be. So let me select them. So I'm going to carefully do this. See how I'm just moving my mouse pointer down just to select those. Those guys have to be bigger than what they are right now. So let's see here. Can I go to size? And let's see, it says the width is 500. What should that width be? Well, let's see here. If that's 16 and 16 times 40, so what's 16 times 40? Well, that would be 400 plus 240, so it's 640. So I think if I change that to 640, I should be golden. Let's see here. Let me change the width to 640. Enter. One too many, so 600, sorry. 600. There we go. Look at that. I better save my work before anything bad happens. Okay, so that's how we create this grid. Now, I think I overkilled it by doing a delta of 40, right? There's 40 between either the horizontal or the vertical axis. It's probably going to be like maybe 30, maybe 20, so I think I did overkill here, but that's okay. Just showing you the spontaneity here of a programmer. All right, the next thing we need to do is to put labels that represent the numbers. So I think I'll just take the toolbox, I'll drag and drop a label over here, and let me see, let me type in the text of 1. Let's see here, if I take that guy and if I put it over here, that doesn't look good. I think I need to move it down a little bit. What if I just change the size a little bit here? So I'll make the auto size false. And what if I changed it so that it's the same height as one of these guys over here, the height of the delta, right, from one line to the next line, something like that. Might that help me out? Well, let's see. Well, first of all, I think I can make the font a little bit bigger. So if I go over here to size and type in 10 points, that looks pretty good. Now, I know that I'm going to have to handle a number that goes all the way up to 15. So let's see what 15 looks like. Yeah, that looks good. Now, I don't want the number like that. I think I want the number to be in the center. So let's see what happens if I say middle center, like that. Okay, and then what I'm going to do is I'm going to move this thing up. So maybe up. I'm going to use my arrows right there. See how I am using this line to kind of intersect that little square right there? So something like that. Okay. In fact, I really could make that font a little bit bigger. So let me do that. I'll say the font size. What does 16 points look like? That looks pretty good. I like that. So I'll make that 16 points. Okay, now let me take, but I don't want to cover. See how it's kind of covering that line right there? So let me take this guy and move it back a little bit to the left. Oh, that's nice. I'll take this guy, copy and paste it. Okay, so what I did was to create these labels and populate them across each of the different rows for my Cartesian coordinate. All I did was just simply take a label, and as you can see over here, made the auto size feature false. And let's see, what did I do? I think I changed the size to, well, in this case it's X, its width is 36, but its height is 40. That's the most important part, because once I establish this one, then all the others kind of stack on top. Then I'm simply going to take these and copy and paste them. So I'll take this guy over here, copy and paste, and then I'll move that over here. And what I'm trying to do is I'm trying to move it right there on this particular column to represent the y-axis. Now, it looks like I'm covering the line here, so I'm going to use my arrows to center this and make sure it's not covering the line. When I unselect it, yeah, that looks pretty good right there. So now I'll take the 2 and I'll carefully copy and paste that and place it right next to it like this. Let's see, that looks pretty good right there. Well, I don't like that, because what I'm trying to do is I'm trying to get that button right there, that resizing button, to be centered across that line. So I had to use my arrows to bump it over a little bit. So I'll just do the same thing over here to 3. And I have a feeling I'm going to be doing this for all of them. That is, using the arrows to bump down. So let me bump over a little bit here. That looks good. Select 4, copy and paste. First, I got to make sure I get that down. That's good. And then bump over a little bit. That's fine. And let's see here, let me take number 5, copy and paste that. Bump it over a little bit. Looks like all I had to bump it over by 2. Copy and paste. 1, 2, bump it over. And let's see here, let's go over here. Copy and paste. Right there. Yeah, that looks good. Okay, so I'm going to stop the video here, and basically I'm just going to fill it all the way to 15. All right, now that I've completed all the labels over here for the y-axis and also for the x-axis, let me go ahead and bring in the houses. So I think I will just go ahead and take a label like this guy over here, copy and paste it. Here it is. And let me change the text to H1, which will represent house 1. And the font is probably a little bit too big. Let's change the size. Let's see what 12 points looks like. Yeah, that looks fine. And I think according to the handout, yeah, it looks like they're bluish in terms of the font color. So what that means is I'm going to have to go over here to the 4 color. Let's see here. There's back color. Where is the 4 color? There it is, 4 color. I'm going to click the drop down, click on custom, and then I'm going to select this blue paint chip right here. And let's see what happens if I make this thing bold. So bold, true. Let me double click here. I like that. That looks good. I'm just going to go ahead and place these somewhere over here because when I first start the game, these are going to be invisible. The visible property, that is going to be set to false. So I'll just have them lined up over here. So I'll take this guy over here and copy and paste it. And oops, I didn't select it, sorry. Copy and paste. We'll change that to H2. And click over here and paste. And we'll change this to H3. And then I'm going to paste. And this is going to be WT. That's going to be my water tower. So you see on my handout that the water tower is supposed to be a red font. So we'll change that 4 color to red. All right, looks good. All right, let's see, what else do I have to create? It looks like I have to create a group box, label, label, drop down, drop down. Okay, well, first of all, let me switch back over here and go to the toolbox. Containers, group box. Let me drag that over here. So here's a group box over here. Open up the form just a little bit here. What is the group box supposed to say? House 1. Okay, so let me select this. Change the text property to house 1. And I think that font size is a little bit too small. So I'm going to go over here to the font property size and type in the number 12. That's better. Okay, what else am I supposed to do? 2 labels. So I think I'll just take 1 label. Let's see here. I'll just take this label, drag it and drop it into here. And that's supposed to say X coordinate. Like that. And I'll just put that over here on the upper left-hand corner of the group box. And then I'm supposed to have a drop down. Okay, so we call those combo boxes. I'll just take this combo box, drag it down over here. And let's see here, let me make it so that it's the same size as that label. So first of all, I'm going to use these guidelines to help me out. Something like that looks good. It looks like it's the same width as the label. And okay, so for this guy, I guess, no, that's fine. That's fine. What do I have is fine. You know what? I'm thinking there's too much space over here. And because if I have to copy and paste this and put it over here, then I'm going to have to open up the form a little bit more. My temptation is to want to select all this and move it over. That's okay. I'll just make this bigger. These are the kind of questions that go on in a developer's mind here. So I'll select this label. I'll select this label. Now, how did I do that? I select this, hold down Shift on the keyboard, select this. Now that they're both selected, I'll Control-C, Control-V as in Victor, copy and paste, put it right next to there like that. And then obviously I can reduce the size of the group box to, I don't know, something like this. Looks pretty good. That needs to change to Y coordinate. All right, so I think that takes care of one group box. I have two more to create. So I think what I'll do is, well, actually, before I do that, now these group boxes, when I click on them, the first item is going to be blank, and then I'm going to have 1, 2, 3, all the way to 15. So let me go ahead and, before I copy and paste, let me do that now so that I don't have to reproduce my work. So let me go ahead and select this, and you'll see over here in the properties, let's see here if I can find, I always forget where I can actually type in that data here. So let me just kind of take a quick look here. And items, that's it right there. Let me click this button, and so what this allows me to do is it allows me to type in what are those items that I want to display when I click on the drop down. So the first thing I'm going to do is I'm going to press enter, because the first thing I want to display is a blank, which means nothing. I'm selecting nothing, and then if you want, you can select the number 1, 2, 3, so forth and so on. What am I at? 7, 8, 9, 10, 11, 12, 13, 14, 15. All right. In fact, I'm going to take this copy, select all, Control A, Control C. Let me click OK, and I'm going to do the same thing over here for its items. And I'll just simply paste. And yeah, space, and then 1, 2, 3, 4, 5, 6, 7, 8, 9. Actually, you know, it is possible that someone might want to put something on the 0 axis, like if we want to place a house right here. I mean, that is possible. So probably what I should have done is I should say 0 is the first number, and then 1 all the way to 15. So let me do the same thing over here, make a quick adjustment. I'm going to go to items and enter. 0 is really the first item here, because it is possible for the user to put a house on the 0 axis here or over here. Okay, now I'll take this guy, select it, copy and paste, and then I'll just put it over here like this. I have to change the text property from house 1 to house 2. Let me click over here in a blank area, paste, and then I'll align these guys. That looks pretty good. Change that to house 3. Okay, and well, it looks like this is kind of higher, right, than this one is here. So let me move this up a little bit, maybe something like that. And then I can make an adjustment by moving this up and over a little bit. And same thing over here. I'm trying to make it so that it looks as symmetrical as possible. Let's see here. That space is much bigger, I think, than this space over here. So let me move this down one notch here. How's that? Yeah, that looks like that space is the same as that space. That's good enough. Okay, then I have some buttons, 4 buttons specifically. This one says show houses. Okay, so I'll go over here to the toolbox, drag and drop a button over here. It's going to be as wide as the group box, so I'm changing that. And I don't know about the size yet, so, or about the height, I should say. So let me leave that as is. I'm going to change the font property, or font size, I should say, to 12 points. And I think this one's over here supposed to say show houses. Okay, looks pretty good. And let me double click, no, sorry, not double click, copy and paste. So I want 4 more of these. Paste and paste. Well, let me see here. I'm trying to make it so that the space is the same here, but I can do that later on. No worries. Okay, let's see here. Show tower, clear, exit. So this is show tower, clear, and this is exit. Okay. All right, so I want this to be over here, and I want this one to be all the way, right here is fine, and like on the bottom of this axis right here. And I'm going to change the size of all these. So first of all, let's make this just a little bit bigger like this. Yeah, like this. And then remember, source, destination. So this is the source, and then these are the guys that are going to be the destination. And I want to make every one of these, or these three, the same as this in terms of height. So let's see here. What is this guy? No, that's not it. How about this guy over here? Yep, no, that's not it. I want to make the height the same. Oh, there it is. Make height the same. Okay, so now the height of these three are the same as these. Now what I'm going to do is I'm going to unselect. I'm going to move this over here. So see that blue guideline right here that indicates that it's at the bottom of that axis right there? Perfect. Okay, now I want these to all have the same spacing in between. So I'll just select this, hold down Shift. I'm still holding down Shift while I'm selecting these. And I want same spacing. Make vertical spacing equal. So I'll click this guy. Yeah, nice. Unselect. Okay, looks good. Let's see here. Do I have any? Let me see, BTN show houses. Okay, good. So I do have some software requirements in terms of what the names are going to be. It looks like this is going to be BTN show houses. Next we have BTN show tower. We have BTN clear. And also BTN exit. All right, combo box. Let me switch back over here to Visual Studio. When I dragged and dropped these drop downs, I call them drop downs, but what do they call them over here? They call them combo boxes. A combo box is basically when you click this arrow and it drops down and gives you all the options. And it looks like the Hungarian notation for that is CMB. So it looks like we have CMB H1 for house 1 x-axis, CMB H1 Y for y-axis. So let me do the CMB H1X first, which is this guy over here. CMB H1X. And I think what I'll do is I'll just select all this and copy it. And over here, I'm going to paste and change that to the y-axis. For this guy, paste it, and I'm going to change that number to 2 because this is house 2 x-axis, or x-coordinate. And then I'm going to paste over here, and I have that change that I've got to make, H2Y. And then finally, paste, this is going to be house number 3 x-axis. And over here, paste, this is going to be, oops, sorry, to do that, paste, this is going to be house number 3 y-axis. Enter. Okay, and then I have these houses over here, this H1, 2, 3, and the water tower. Those are labels, so I've got to label them appropriately. It looks like it's LBL H1. Okay, so I'll select this guy over here. LBL H1. Hey, where'd this button come from? I don't know when I put that there. Let me get rid of it. All right, so let me see here. LBL H1, good. This is going to be LBL H2. In fact, let me just copy and paste the name and make a change. So copy that over here, paste, and change that to H2. Select this, paste, and make that H3, LBL H3. And then the water tower is supposed to be LBL tower. Okay? So I'll select this guy over here, LBL tower. Let me save my work. Go back over here. Let's just make sure that I've named everything appropriately. Yeah, this is about the distance equation. We know about that already. So I've named all these guys. I've named these guys right here. I think we're ready to go. So let's do this. Let's make it, first of all, let's handle the easy program, which is this guy right here, the exit button. When I click this, we're going to quit the program. So let me double click. That's going to take me into the code area. And I'm just simply going to say close. Open and close parentheses. I could put this dot close. That'd be okay as well. Either one is acceptable. Run the program. Let's see what happens. All right, so we're building it. It's taking its sweet time. Oh, I like this. Oh, wait, what did I forget to do? I forgot to rename this here. And I forgot to make these invisible. Okay. And I think I should make the form just a little bit taller, right? The height should be something like that. Let's see here. If I click one of these guys, yep, it displays all the various items here. That's good. Did I put one too many over here? Yeah, look at that. I got to get rid of that one. And that's the problem with all these here. Okay, so specifically for the y-axis, I got to change that. These buttons don't work yet. We're going to make this button work. What we already have, just by simply clicking it, should exit the program. And there it is. We're no longer running. That's good. Well, first of all, let me make these design changes. So let me select this guy over here, go to Properties, and specifically Items. Here it is. And it looks like I have to get rid of one of these spaces, so I'll just simply delete. And I'll do the same thing for all these. And finally this one. Okay, good. And then I don't want these guys over here, the house 1 through 3 label, including the water tower, to be visible. So let me select this one, hold Shift, select this one, and this one. So now I've selected all of them. I've just let go of Shift. I'm going to go to the visible property and set that to false. So they exist here in design view, and you can see them. Actually, I shouldn't say they exist. You can see them in design view, but they're going to be invisible when I run the program. I think I also wanted to make the form just a little taller, so let me select the form and make this just a little bit taller like that. Okay, I think that's better. And I don't want that to say Form 1. What is that supposed to say? Water tower calculation. Okay, so with the form selected, we go over here to the text property and say water tower calculation. Enter. All right, better. And it looks like no minimize, no maximize box. So let me see here. Maximize box false, minimize box false. Let me save my work, run the program. Wow, that's looking pretty good. And yeah, probably too much space here, but that's okay. I'm being picky. And it looks like for the y-axis, or for the y-coordinate, we only have that one space, which is initially going to be blank. I like that. And these buttons don't work yet, but this clear button should work. No labels over here. H1, H2, H3, water tower, nothing there. Good. Click exit. It's probably too much space over here. So I'm going to reduce the space a little bit. Something like that. Get rid of this output panel. All right, let me go ahead and click Save. And it looks like we're finished with the graphical user interface. We've just entered the code for exit. And now let's go ahead and deal with the code for clear. Okay, I'm going to double click the clear button, and I'm going to type the following comments first. So the first thing I need to do is I need to set the combo boxes to blank, and then I need to make the house, or the houses, no, I shouldn't say houses, house and tower labels not visible. And then finally, we're going to disable the show tower button. Because either you are showing, once you show the houses, then you can show the tower. But if you're clearing everything, then we don't want to say show tower because the houses have not been shown. They're not displayed. So that's the reasoning for this. Okay, so that's my pseudocode. This is what I need to do. Well, first of all, how do I set the combo boxes to blank? You'll recall, let me run the program, that when I click on a particular drop-down, the first item is blank. And so really what I want to do is I want to set the blank for all of these combo boxes. Okay. So how do you do that? Well, let me go back over here to the code. And what we're going to do is we're going to say CMB, which is the Hungarian notation for combo box. H1X, we'll deal with that one first. Dot selected index. We'll say that that's going to be 0. So what this does is it says which one of those items, the blank, the 0, the 1, for these drop downs, the first item was blank, then 1, 0, 1, 2, 3, 4, so forth and so on. Which one do you want selected? And I'm saying the 0 one. Now let me on purpose put in the number 5. Okay, and let's see what happens. So when I click clear, see combo box H1X selected index should go to 5. So let's see what happens. Let me run the program. Let me click clear, and notice what happened. It's the 5th item that was selected. 0, 1, 2, 3, 4, 5. That's the 5th index right there, and that's why it's displaying 4. So that's what I mean by clear. But now, of course, I don't want to select that 5th index. I want to select that 0 index, which is the first item. I know that's kind of weird, but computer scientists, we say the 0 index or the first element, or 0 index or the first item. We like counting from 0, and so the 0 index really is the first item. So that's what I mean by this. And let me do the same thing for CMB H1Y dot selected index. Again, we're going to select that 0 index of the first item. I'm going to take these two, copy and paste. So copy and paste and paste. And I'm going to change this to the number 2. In fact, let me go into overwrite mode. So double click over here, and then I'm just going to use my arrows. This is supposed to be 2, this is supposed to be 2, this is supposed to be 3, this is supposed to be 3. I'm using the arrows as well to go from item to item. Then we get out of the overwrite mode by double clicking it, going back to insert. Okay, that takes care of this. Make house and tower labels not visible. Okay, so the way that we're going to do that is we're going to say LBL H1 dot the visible property. This is it, the visible property. We're going to set you to false. Okay, I'll take this guy over here, copy and paste, copy and paste, paste. Go back to the overwrite mode, change this to house 2 and change this to house 3. Then we get out of the overwrite mode and go back into the insert mode. And also the water tower. Oh, don't forget the water tower. LBL, this guy right here, the water tower dot visible. Set that to false. All right, next we're going to disable the show tower. So I'm not saying make it invisible. I'm saying make it disabled. So before I show you that, let me just run the program. And here's disabled. So you see what it looks like. Here it is enabled rather. If I click down, you can see that it's being clicked. Okay, now let me select the show tower. And over here where it says enabled, true, I'm going to make it enabled false. So let's see what happens now when I run the program. So you can see right here, it is disabled. So I hover on top of this button, this button, this button. But if I hover on top of this, if I click, nothing happens. Why? Because the button is disabled. So that's what the enabled disabled property does. So in fact, I'm going to leave it disabled right now, right off the bat, because when I first start the program, it's supposed to be disabled. I should only be able to show the houses. And then, of course, when I click the clear button, if the show tower happens to be enabled, then I have to disable it. So how do I do that? So I'll say btn show tower dot enabled property. We're going to set that to false. Okay. Save my work. Let's run the program. Let's pretend that I'm selecting several X and Y axis coordinates for house 1 through house 3. Okay, so here we are. And let me go ahead and click clear. Perfect, so all of those have been cleared. This is disabled. Everything looks good. Let me click exit. Okay, let me close the output panel. Let's go ahead and save our work and go back over here to the design panel. And we are now ready to work on show houses. And then I'll work on show tower. All right, this is probably going to be the most, not complicated, involved perhaps is the better word. This is going to be the most involved button to deal with, because when I click show houses, I have to read these coordinates and then apply them to H1, H2, and H3. But remember, when I'm applying them, to the various houses, this is not the origin. That's the absolute origin. This is the 0, 0 location of the form. This right here is the relative origin to the grid that I have here, the Cartesian coordinate. In fact, let me select H1 and let's change its location to 0, 0 just to see what happens. Look at this. So it moves it to the upper left-hand corner. That little dot right there, the resizing handle, this guy right here, that currently is at 0, 0. So you see that the label has an anchor on the upper left-hand corner. This thing is at 0, 0, and that's what it looks like right there. Well, what happens if I want to find out where the origin is? And so let me scroll down a little bit here. Scroll down, select this guy, and it looks like the origin. Well, that's not really the origin. Let me use my arrow keys to move it over a little bit. It looks like that H1 is right there on top of that origin. And so what is that location? It looks like it's 82, 610. So for me, my origin is at x-axis 82, y-axis 610. Now, that's not going to be the case for you. When you move your label and put it right there at the origin, you're probably going to have different values than I have. So it's important for you to do exactly what I just did. Move your house right there at that location and figure out what your origin is. Because now what I need to do in code is I need to create an x and y-axis origin variable with x equal to 82 and y equal to 610. So in fact, I'm going to do that. Now, the way that I'm going to do that is I'm going to create global variables, and I'll explain that later, why I'm doing this. But I can just put it right here, I guess, and I'll just say global. Sometimes people call them modular variables. And what I'm going to do is I'm going to create two integers. One is going to be called x origin, and we're going to set that to, oh gosh, I already forgot. Let's see here. What is this guy at? Location 82, 610. Okay, so 82, and the other one, the y origin, is at 610. So again, don't type these numbers. Those are my numbers for my specific origin. You're going to have to move a label over here and then go to the properties panel and then ask, okay, so where is the origin? And so you can just simply look at the location, and right here it tells you, or you can click this and see what x and y axis, that's what it means. This is the x-axis, the second number is the y-axis after the comma. And so for me, that's my origin, so that's why I placed that there. Okay, let me go back over here to the code area. And one of the things I'm going to need to do is to determine where the house 1 x-axis is located, and also the same thing with the house 1 y-axis. And I'll just simply copy and paste these two. Copy, paste, enter, paste, and I'm going to go into the overwrite mode and change these appropriately. So that's supposed to be 2, 2, this is supposed to be 3, 3. Get out of the overwrite mode, scroll down. Okay, now I'm going to create a variable called min tower x. I'm also going to create min tower y. Now, what I mean by that is, where do I need to move this tower such that it yields the minimal total distance that we spoke about earlier in this lecture? So, shall it be here? Or should it be here? Or should it be here? So, wherever that tower is that leads to the minimal value, I want to remember that, because that's the solution. Where should the tower go? Wherever it creates the minimal total distance. So I'm just going to call those min tower x, min tower y. All right, and then finally, let me create a variable called delta, and I'm going to set this to 40. Now, what is that? Well, you'll recall that these lines are 40 pixels apart, or 40 points apart. And so if I want to move a label from here up to here, that's 40 in distance. If I want to move a label from here to here, that's 40 in distance. So I'm going to call that my delta, right? Physicists typically talk about the distance between point 1 and point 2. They typically refer to that as the Greek letter delta. So we're just simply going to write this down. And I'll just put a quick comment over here. This is going to be the distance from one grid, from one grid line to the next. All right, so that's what my delta is. So let me save my work. Here we go. Okay, so now we're ready to work on showing the houses. Let's see here. Back over here to design. Double click on show houses. All right, so the first thing that I'm going to need to do is to assign the text box values to variables. Actually, I don't have text boxes. I have combo boxes. Right? I have to get these values here because remember these are holding text items or string items, and I need to convert those to numbers. So that's what I mean. If the user selects 3, we need to not select this. We need to convert this string text into the number 3. Right? So that's what this is all about. We're going to have to assign those. Then I'm going to need to position each label based on the user entry. I need to reveal the house marker labels. In other words, make them visible, because they're all invisible at the game start, or sorry, at the program start. And then finally, I need to enable the tower button. So this is what I like to do. I like to create pseudocode, which are basically just comments. Pseudo means kind of fake or almost or false. Pseudocode is basically a computer scientist's tool to say, okay, what is the big picture? What do I need to do? And I'm not going to write code yet. I'm going to write the ideas of this needs to be done first, this needs to be done second. And so a lot of programmers will do this. They'll write pseudocode in the form of comments like this. This needs to be done first, then second, then third, so forth and so on. And then the code that you write underneath each of these sections will be elaborated in detail via code, but the idea is up here. So in other words, programmers need to have the bird's eye perspective and the worm's eye perspective. The bird's eye perspective is this right here. You're at the top flying around, you see the trees, you see the river cutting through the forest. And then the code that we type, that's the worm's eye view. So the worm's eye perspective, the worm sees the blade of grass and little bits and pieces of dirt. That's the nitty-gritty detail of our code. So we've just exited out of our bird's eye perspective, and now we're going to type the code, which is the worm's eye perspective. So when it says assign the combo box values to variables, I've already created those values, or those variables, h1x. What is that going to be? Okay, I'm going to type this, but then I'm going to change it. So combo box h1x dot text. Okay, so that's a text, as you can see here, and it returns a string. And I'm going to do this. Okay, so the idea is I'm trying to get the text property from the combo box, which is one of those numbers from 0 to 15, and I'm trying to place it into this variable, but I can't do that because this right here is an integer. See that word int right there? That's an integer. Whereas the text property, if I'm getting the text of this combo box, that's a string. See, that's a string. So what I'm going to have to do first is convert dot to int 32. Well, it's not letting me display it, so I'll just do this. Convert to int 32. Now the reason why we convert to a 32-bit integer is because this makes it backward compatible with Windows 7, even all the way back to Windows XP. An integer is defined as a 32-bit integer. So if I knew that my program was going to be run on all the latest and greatest Intel processors, then I could make that to int 64. But I don't want to take that chance. I'm going to make it backward compatible. Parens combo box h1x dot text. Okay, so now what we're doing is we're getting the text property from the combo box, whatever that happens to be, whatever it's displaying. We're going to convert that into a whole number and assign that into h1x. And we'll do the same thing with h1y. Say convert dot to int 32, take the combo box h1y dot text. Okay, let's take these two, copy, and I'm going to paste, and go into insert mode, and I'm going to change these values. So this will be 2, 2, this will be 3, 3, and let me go over here and change the combo boxes as well. This will be 2, 2, 3, 3. Let me get out of overwrite mode, double click, and now I'm back into insert mode. Okay, I'm going to skip this section temporarily, and let me just show you something. I'll share that with you last. All right, so let's go back over here, forward over here to reveal house markers. That's simple. That's LBL h1.visible is going to be set to true. And I'll just take this, copy, paste, go into overwrite mode, and we're going to change that to the number 2 and this to the number 3. Get out of overwrite mode. Here we go. And then finally, the last thing to do is to enable the tower button. So that's going to be btn show tower. Where's show tower? There it is. Dot enabled, and we'll set that to true. All right, so that looks good right there. Let me save my work. And now we can talk about position each label based on the user entry. Okay, I paused the video, typed this code to verify that it would work, and so it did. So now let's go ahead and talk about it. All right, well, first of all, each of these different labels, the house 1 label, the house 2, house 3, and also the water tower later on, they have a dot left and a dot top property. Now, what that means is where is the number of pixels, or the location of the number of pixels from the top left corner? That's basically what we're doing. In fact, if I were to do this, if I said LBLH1 dot top, say for example, look at the description that it gives. Gets or sets the distance in pixels between the top edge of the control and the top edge of its container's client area. Put another way, get rid of that. Put another way, the left and the top refer to this location. Oops, let me scroll up a little bit. They refer to this location right here. So from this top left corner, how much do you want to move away, or how much do you want to move down? That's what I'm going to use to move these labels. For example, if the user selected 1 and 1 over here, then this has to move over here, like this, to this location. Now, I know that that looks like this is at 1, 1, but this is really not at 1, 1. Where is this thing located? This thing is located at 123, 272, or 572 rather. All right, so we think of this as 1, 1 because that's the user's perspective, this relative graph or grid that I have, but really that's the 0, 0 location. I am moving over 123 to the x-axis and moving down 572 pixels, right? And to be able to get this label down here. Gosh, I don't want to have to do all that and figure out all that. Let's see, is there a better way of making it so that these labels are going to appear in their appropriate location? Maybe I can enter a mathematical formula to make that happen, and that's what this is all about. So let's take this step by step, and I think that you'll be able to understand it if I go slowly and show you what I'm talking about. Okay, well, first of all, let's start this guy off at a 0, 0. Okay, so let me type in location 0, 0. Okay, so that's where the label is. The user is going to click Show Houses, and this one says 1, 1, which means that we're going to have to move the house to this location right here. We are currently right here. All right, so notice what the equation says. It says, in terms of moving it from this left-hand position, what are we going to do? Well, first of all, we're going to assign this value to the origin. Well, we did that already. Back over here, we set the origin to 82 and 610. Okay, so 82 and 610. Go to show houses. Here it is. All right. So this right here, I should have just split the screen, make this a little bit easier to see. And I'm going to go over here to the top. Let's see if I can find those global variables. There they are. Okay. So the X origin is set to 82. So that's the first thing I'm going to do. I'm going to move this from the left-hand position 82 pixels. Okay. So let's say select that. And let's see here. Let's go to origin. And we're going to move this 82. So let me type in 82. Enter. Okay, so now I've moved that over as if it were over here at the 0 axis, but it's over here at the top. That's what I've done so far. Okay, so what else am I supposed to do? I'm supposed to add to that h1x times delta. Well, delta is the distance between the one grid line to another, and that's set to 40. Now, it looks like h1x, if the user puts in 1 over here and 1 over here, if the user puts in 1, that means that they want it right here. So how am I going to get this to move a little bit over? Well, what I do is I multiply whatever h1x is, which in this case is 1, right? The user put the number 1 right here. So 1 times 40 is 40. So in other words, take this guy right here, which is currently at my origin, and add to it an additional 40. So if I add to it an additional 40, so let's see where the location is. Currently that's at 82. Well, that's going to be what? 92, 102, 112, 122? So 122, enter. And do you see how I moved over? Now it's on the 1 axis right here. Okay, let's do the same thing now for the y-axis. And so from the top location, I want you to go to the y origin. Well, the y origin, what is that? We already set that. That's 610. Okay, so over here, to the location, for the y origin, let's set you to 610. So 610 is right here. So in other words, that's all the way at this bottom 0 x-axis or y-axis right here. Okay, so that's all the way in the bottom. Now, remember, the user typed in 1, 1. They entered the 1 for the x-coordinate. So this thing has to move up to this location right here where this intersection is. But remember, when I move up, I'm subtracting because this is 0. 10, 20, 30, 40, 50, 60, 70, blah, 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 blah. So let's say that this is 600. To go back down, 500, 400, 300, 200, right? So when I move up, I'm subtracting numbers. So that's why you see over here it says minus whatever h1y is times delta. Well, first of all, what is h1y? That's the user's number. And let's just say that they entered the number 1. They entered 1, 1. But specifically for the y-axis, they entered the number 1. So 1 times the delta, and I already showed you that the delta is 40. That's the distance between these grid lines. We established that on our design. So 1 times the delta is 40. So whatever that y origin is, subtract 40 from it. Okay. So currently it's set to 610, and so minus 40 would be 570. So type in 570. Oops, sorry. 70. Enter. And now notice what happens. This label is at the 1, 1 location. Okay, so let's now apply that same idea to house 2, x and y axis, and also house 3, x and y axis. So actually, over here. House 2 and house 3, x and y axis. From the top left corner, here's how much we're going to move in the x direction, here's how much we're going to move in the y direction. And basically what these equations do is they give us the ability to move the label physically on our form. So let me save my work, and I'm going to go ahead and run the program, and let's see what happens. Well, the first thing that I'm going to do is, well, when it comes up, first of all, is I'm going to change the x and y axis coordinate for house 1. I'll put the house number 1 right here. Let's put the house number 2 somewhere over here. What is that? Looks like it's x-axis 8, y-axis 15. And then I'll put the third house, say for example, right here, 13, 2. 13, 2, like that. Click Show Houses, and notice what happens. Now the houses are placed at those intersections. It should be at 1, 1, yep. Next one's at 8, 15, 8, 15, yep. Next one's at 13, 2, yep, 13, 2. And also notice that the Show Tower button has been enabled. So now I can click Show Tower, which is going to put the tower somewhere over here. It's going to determine what that centroid position is based on the triangle that's formed by these three houses. We're going to place this in a position where it creates the minimal total distance, because linear galvanized pipe is very expensive, and we want that to be as cheap as possible. So where is that tower supposed to be located? Well, we're going to click Show Tower and work on that code next. Well, the first thing I'm going to do is to click Exit so we can get out of the program. And now I'm going to double click on the Show Tower button so we can work on that code. I don't need properties, and I don't need to split the screen, so let me get rid of that. Okay, well, in terms of showing the tower, first of all, there's definitely variables that I'm going to declare, so we'll say declarations. And what I'm going to need to do is to calculate the centroid of the triangle formed by the three, I'll just say three, houses. Then the next thing to do is to make the tower visible and assign its position on the grid. These are the three things that I need to do to display the tower. It's got to be displayed appropriately. Let me go back to my graphic over here. I'm going to take each of these different locations. I'll move the water tower from the 0, 0 location. And then I'm going to move it one by one to each of these different locations to determine what the distance is. If a distance is less than the previous one, that becomes my new best location for the water tower. I don't have to go row by row. I could also go column by column. I can go from here to here to here to here. And then I can go back down over here and investigate each of these different intersections. And I'm going to keep track of that particular water tower location that yields the least distance. And if that's the case, then I can go back, or I can set that new location as the best one so far. Okay, so back over here, let me create the following declarations. So I'm going to create tx, which is the tower x-axis location, as an integer. We'll do the same thing, ty. I'm going to create a total distance. Now for this one, I'm going to create this as a double total distance, because I could have 45 for a particular x and y axis location of a tower, and one is 45.2, the other one is 45.9. So I'd better make this a double, because I want to take into consideration the least total distance with as much accuracy as possible. So making it a double is going to help me out. And then, okay, now this is not an elegant approach, what I'm about to do, but it's a good beginner's way of thinking about it. When we revisit this program, when we deal with functions, then I'm going to show you a more elegant approach. Notice I have really not talked about this green line right here. When we talk about functions, then this bounding box is going to make more sense. But for right now, we're just going to move the water tower from the 0, 0 location all the way to the 15, 15 location, which is where we're up here. And so I'm going to do the following. I'm going to create a double called min distance. Minimum distance. And I'm going to initialize this to, I don't know, let's just say 100,000. Now, this is a ridiculously large number, so that when I move the water tower here and check it out at its 0, 0 location and check the distance from here to the house 1, house 2, house 3, clearly that total distance is going to be less than 100,000. So in other words, we're going to be able to replace this. So I set it to a very large number. I could set this to 1 million if I wanted to. 10 million, 100 million. Something really large that it's going to guarantee to be replaced. Again, I don't think this is an elegant solution, but at least it communicates, it helps me to communicate an easy concept of replacement. And then, like I said before, when we deal with functions, we won't use this approach. We'll use a better approach or a more elegant approach. All right, so we're ready for this section over here where it says calculate the centroid of the triangle formed by the three houses. All right, what we'll do in terms of calculating where that point is we'll move the water tower first over here to 0, 0. Then we'll move it over here and determine the max distance. Then we'll move it over here and I shouldn't say the max, the total distance. We'll move it over here, and then here, and then here, and so forth and so on. We're going to move it to these various locations. Well, probably one of the easiest ways to do that is to use a looping structure. So what I could do is this. I could say, okay, for, and we'll let tx start off at 0. And then we're going to keep on doing this as long as tx is less than or equal to 15. And I don't like that hard coding, so we better take care of that in just a moment. And then we'll simply say tx plus plus, which means we're going to increment it by 1. Within that, I'm going to have another for statement dealing with ty, which is going to start off at 0. Ty, as long as this is less than or equal to 15, and ty will be incremented step by step, open and close curly braces. Now I don't like this 15 right here and the 15 over here, so maybe I should go ahead and create a constant. 2 constants. Well, then one constant. Let's see here. So let's create a constant. It's going to be an integer, and we'll say this is max x-axis. Maybe I'll put an underscore. Underscore x-axis, and we'll set that to 15. And I'll do the same thing over here. So I'll say const int max underscore y-axis, and we'll set that to 15. Well, this way I'm not going to be doing any hard coding. I can replace this, copy this guy over here, and replace this. And that way, if I ever need to change whatever the x and y axis is, I can just change it over here, change what the constant is. And I avoid this potential problem of hard coding. Okay, I think that's it. All right, so now we need to determine what the total distance is. Remember, the total distance is going to be from house 1 to the water tower. That's 1 distance. From the water tower to house 2, that's the second distance. From the water tower to house 3, that's the third distance. And then we add those up, and then we're going to get our total distance. Okay, we're not working with functions right now. When we work with functions, this problem is going to be really easy. But we're not working with functions, so it's going to take a little bit of typing here. So let's do the following. First of all, the idea is with these nested for loops, start off with the tower at the 0, 0 location. So we're going to start off with the tower right here. Then, then once we've done this x-axis 0, okay, y-axis 0, y-axis 1, y-axis 2, all the way to 15. In essence, what we're doing is we're moving the water tower from here to here to here. Actually, well, I take that back. It's y-axis, right? Yeah, so the x-axis means moving it over here, 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 here. The y-axis means we're taking this guy and moving it from here to here to here to here. And then finally, when we move it all the way to the top, then we go to the next column. And here to here. And during all those locations, we are determining what the total distance is. How are we going to solve for that total distance? Say total distance is going to be, okay, so first of all, we need to use the distance equation, which I think I gave you in the handout. There it is. We need to determine what the distance is from the water tower to the house. And this is the equation that we need to use. So why don't we let the 1 values be the tower, and the 2 values will be the house. Okay? So let's do this. It looks like the total distance is going to be math.sqrt. Let me open and close the parentheses, put a semicolon over there. So that takes care of the square root. Inside the square root, I have this quantity squared. So that's going to be math.pow. So over here, math.pow, open and close parentheses, plus math.pow, open and close parentheses, right? So this is squared plus this is going to be squared. So this is squared plus this is going to be squared. All right, well, what are we going to square? First of all, we're going to deal with the the x-axis for the house minus the tower. Okay, so the house is h1x minus the tower, which is tx. And we're going to say comma 2.0 because that means this difference has to be squared, because that's what we're doing over here. This difference has to be squared. So that's how we set it up over here for math.pow. We're going to do the same thing over here, but we're dealing with the y-axis. So house minus the tower location for the y-axis. For the house, h1y minus ty, comma 2.0. Enter. Okay, so this is the distance for house 1 to the tower. So I'm going to have to add that to the house 2 distance. So I'll just take this guy over here, copy, and paste right here. But I have to change those to house 2. So go into overwrite mode. Let's change that to a 2. Let's change this to a 2 because that's the distance for house number 2. Get out of override mode. And then I also have to consider house number 3. So we'll say plus, let me paste, go into overwrite mode, and then deal with house number 3. And house number 3, get out of overwrite mode. So basically what this is this guy down here. Distance 1 plus distance 2 plus distance 3. Distance 1 plus distance 2 plus distance 3. That's what I've done here in the code. Here's distance 1. In fact, if I hit enter here, maybe that'll be easier to see. So here's the distance 1, here's the distance 2, here's the distance 3, and we're adding all those together. And that is going to make up my total distance. Now that I have the total distance, if the total distance is less than the minimum distance, which is what I have so far. I have a minimum distance of 100,000. If this new total distance is less than the minimum distance, well then I have a new minimum distance that I've got to establish. And the way that I'll do that is as follows. I'll say the new minimum distance is going to be whatever the total distance currently is. And by the way, I better remember your location. And the way that I'm going to remember your location is using that variable that I created called minimum tower x. We're going to set that to tx. And the minimum tower y, we're going to set that to ty. Let's dive into this a little bit more. I've just found out what the distance is from the tower to all 3 houses. So from the tower to house 1, house 2, house 3. And I have that total distance. Is that new total distance less than my previous minimum distance? Because if it is, not only do I want to remember that new minimum distance, I want to remember where the tower is that generated that minimum distance. So every time I go through this, I'm checking, do I have a new minimum distance? Do I have a new minimum distance? Do I have a new minimum distance? If not, then ignore this. But if so, well, I better keep track of that. And by the way, where should that tower be to generate that minimum distance? That's the idea behind this if statement. So this thing is just going to keep on checking every single location. When I run the program, we'll go through this step by step so that you can get a deeper view of what's happening here. Okay, so get rid of this extra space here. And right there, that's good. The next thing to do is to make the tower visible and assign its position on the grid. All right, so we'll say LBL, water tower, right here, dot visible. Yeah, you're visible now. I'm going to make that true. Now I need to move the water tower into position based on this new min tower x and min tower y values that we've just determined. So LBL tower dot top. We've already seen how that works. I'll take the y origin and I'm going to move it down a certain amount. And then I'm going to move it up. So I'll say minus whatever that min tower y value is times delta. And again, this same explanation that I gave you with the houses applies here to the tower. LBL tower dot left, we'll say x origin plus min tower x times delta. Okay. All right. I think that's it. Oops, I said leave. I'm supposed to type in left. This guy right here. Let me save my work, run the program. Let's see what happens. Okay, here's our program. Let me type in, or I should say select various locations here. Here, we'll put that somewhere up here, and then another one down here. So let's say over here, I don't know, 14 points, and 4, say for example. Show the houses. Okay, so here are the house locations. Where should the water tower go? So what we're going to do is our program is going to move the water tower here and then get the total distance. Then here, then here, then here, all the way up. And then it's going to go to the next column, and then the next column, and the next column, and so forth and so on until it finishes up here. By that point, we should have determined the minimum distance, and now we can display that. So that's what show tower does. So show tower is saying that the water tower should be at x-axis 9, y-axis 6. And it's that way when you connect the pipe from here to here, from here to here, from here to here, that is the best location because it yields the minimum distance, which means you're spending the least amount of money on linear galvanized pipe, and that can be very expensive. Let me double check to see if this is correct. So I have that Excel spreadsheet that I mentioned earlier in my video lesson, and let me type some values over here just to see if in fact the Excel spreadsheet agrees with my program. So let me see, the house is at 1, 1. Okay, 1, 1. 8, 15. Okay, so 8, 15. And finally 14, 4. Okay, so 14, 4. So it's saying, my Excel spreadsheet is saying that the x-axis should be at 9, the y-axis should be at 6. The x-axis should be at 9, the y-axis should be at 6. Yep, that's right. That's exactly where it should be. Because notice from this Excel spreadsheet, that generates a total distance of 23.87. And if you look everywhere around, you will not find a number that's less than this. That's why our program said this is the best location, because this yields the smallest distance with the 3 houses located at these particular x-y axis coordinates. So we moved the water tower over here. That yielded that yielded total distance of 28.99. And then we moved it over here. That was 28.6. Ah, that's the best location so far. Then we moved it over here. Oh, that's the best location so far. Why? Because you can see how the number's getting smaller. Now this is the best location. Best, best, best. Oh, look at that. It's increasing. It went from 27.65 to 27.71. So this is the best location. We just tested this, but I'm going to ignore you because this is the better location. Ignore, 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 because none of these are less than 27.65. Ignore, 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 ignore. Go to the next row. Well, actually, we're working ours, in terms of going column, but you get the idea. Let's see. Is there something that's less than 27.65? No, no, no. Oh, right here, 27.34. So now this is what I want to remember right here. Oh, this is 26. This is 26.68. Yep, yep, yep. That's less than or equal to, yeah. We're getting bigger and bigger and bigger, so I'm going to remember you right now. Okay, are you less than 26.4? No, no, no. Yep, I'm going to remember you. Yep, you're getting smaller, getting smaller, getting smaller. That's good. We're getting bigger. So now I'm going to ignore all these. Go back over here. I need something that's less than 25.36. Less than 25.36. Yep. Yep. Looking good. Looking good. We're getting bigger. So I'm going to remember this guy. Less than 24.59. 24.59. Right there. We're smaller than that one. We're smaller than that one. Smaller than that one. So I'm going through this painstakingly to show you how this approach works. Okay, then we go over here. We need something less than 24.09. There. This is smaller than this one. This is larger, so I'm going to ignore all this. All right. So is there anything that's smaller than 23.87? No. 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 And in fact, for the rest of the grid, it's always going to be no. So this ended up being the best location for these house locations. This is a cool little program. This is what I had to do in my bachelor's degree when I first started taking Fortran. And my instructor gave us this idea that we were hired to find out the best water tower location. Now, there's a much easier way to use Euclidean mathematic formula but the idea is to use repetition structure, nested repetition structure, to test each of these different locations for the water tower to find out the best location that will yield the least amount of distance. And that's it. Whew, this was a long video lesson, but you know what? A great, great project to learn about, I guess, graphical user design, to learn about these combo boxes, these group boxes, moving labels around, the idea of clearing, showing houses, showing tower. In fact, if I click clear, everything should go away. Oh, beautiful, it worked. Now, of course, our program isn't entirely robust. It could be that the user does something crazy like selects a blank. I'm assuming that they're not going to do something dumb like that. We're going to assume that the user really does enter values into here, and then they can click show houses, and then they can click show tower, and then they can exit or clear the labels that are on the screen and then start all over again. If we wanted to make our program more robust to deal with this situation where they accidentally click a blank, which you can't convert a blank into a number, we could just simply use a try block, and we could use an if statement. We could use some other approach, display a message box, something like that. But that's not what this video lesson's about. This video lesson's about nested repetition structure for solving a problem like this, and really kind of putting a little bit more of a thought process behind solving a problem like this for a customer. All right, so this is Professor Robert Solis. I hope this video lesson was helpful. Have a good day. See you next time.